Hi there and welcome to another revision video for the Edexcel Core 3 Maths A-Level syllabus. In this video we work through modulus equations, any past paper questions that come up where you have to solve an equation involving a modulus. As always, pause the video to look at a question, work through it and then press play and mark your work against mine. Here's the first question. Okay, for the first part, we're asked to draw the graph y is equal to f of x, where f of x is given by the modulus of 2x subtract 5, where x is a real number. So, how do I go about drawing that graph there? Well, the first thing I'm going to do is I'm going to draw the graph, I'm going to do it over here, I'm going to draw the graph 2x subtract 5. So I'm going to, step 1, I'm going to ignore the fact that there's a modulus. I'm going to draw the graph y is 2x subtract 5. And to do that I need 2 points. So I'm going to let x be 0. And when I let x be 0, y is negative 5. And when I let y be 0, y turns out to be 2.5. So I'm going to have myself the point 0, negative 5 down here. And I'm going to have myself the point 2.50 here. And then I can draw a straight line between these, as such. Now, the modulus of this graph, step 2, actually makes this graph, it defines this graph as follows. It says that it is equal to the positive of the expression inside the brackets. It is the positive 2x minus 5 for x is bigger than or equal to 2.5, and it's going to be the negative of this for x less than 2.5. So actually what we're doing, taking the modulus of this function, is we're actually reflecting this part here in the x-axis. So actually to draw it, I would therefore have it looking something like this. Now, step 3, I might go back to a blue pen. How do I find this point here? Well, to find that point there, I would let this branch of it, the negative 2x subtract 5, I'm trying to find, I'm dealing with this function here, and I'm letting x be 0 in this function. So therefore y would be equal to 5. So this point here would be 0, 5. And obviously it's 0, 5 because it's a reflection of this point here. Now it's important when you draw it, you draw maybe this section with a dotted line, because that should not be included in your graph. This point here was working, so that might be an initial stage of drawing, but that is what the final graph looks like. Next, we are solving when f of x is equal to this. Now let's remember what f of x is. F of x is equal to 2x subtract 5 for x bigger than or equal to 2.5 and negative 2x subtract 5 for x less than 2.5. Now, I'm solving where f of x is equal to this expression here. So I can make this part equal this first, and afterwards I can see if there's a solution for this part equal to this. So there may be 2 solutions. So I'm going to do solution 1. I'm solving where 2x subtract 5 is equal to 15 plus x. And for solution 2, I'm going to solve where 2x subtract 5, the negative of this, in fact, is equal to 15 plus x. Okay then, what we could do is subtract x from both sides and add 5, and I would get straight away that x is 20, and that fits within my range. X is bigger than 2.5, so that seems right. And here, I would get negative 2x plus 5 is 15 plus x. I could add 2x to both sides and subtract 15. I would get negative 10 is equal to 3x, and therefore I would get x is equal to negative 10 over 3. And that is less than 2.5, so again, this seems like a valuable solution. It seems like I've got the correct answer there. And for C, g is defined as follows. Find f of g of 2. Well, g of x is defined to be the function x squared subtract 4x plus 1, and it tells us that x must be between 0 and 5, and it asks us to work out f of g of 2. So before we do that, why don't we work out g of 2? G of 2 would be 2 squared subtract 4 times 2 plus 1, and it would be equal to 4 subtract 8, which is negative 4, plus 1, it would be negative 3. So g of 2 is negative 3. So therefore f of g of 2 is actually f evaluated at negative 3. Well, looking back at our definition of f is two different things for bigger than 2.5 and less than 2.5. And this, if x in particular is negative 3, then this is the one we care about. So what we do is we let x be negative 3 in this expression here. So f of negative 3 would be negative 2x minus 5, so it would be negative 2x subtract 5. So if you work that out, it's negative. This would be minus 6 minus 5, which would be minus 11. So it would be minus 11, and it would in particular be 11. And we're done. And it says work out the range of g. So looking back here, we've got our function g of x is equal to x squared minus 4x plus 1. So x squared minus 4x plus 1. And we've got to be careful, x is between 0 and 5. So 0 less than or equal to x less than or equal to 5. What I can do is I can complete the square of this graph. That would help me see where the minimum or the vertex is. So g of x, completing the square, would be x subtract 2 squared. Square this in your head is 4, subtract it and add the 1, so it would be negative 3 if I did that. So this tells me that the graph, not worrying about the particular domain as yet, but the graph has a vertex at 2, negative 3. So 2 across, negative 3 down. This point here is 2, negative 3. We of course know that when x is 0, it would be equal to 1, so we know it goes through the point 0, 1, and we know at 5, at 5 if we substitute 5 in here, we would get 6. So at the point 5 it would be 6, and we know it's a U shape, and 2, 3 is its minimum, so it looks something as follows. So if I was asked the range is all the y values it can take. Well, it can take anything bigger than or equal to 3, but less than 6. So g of x is less than or equal to 6, but is bigger than or equal to negative 3. That point there should be negative 3, is a mistake. And we're done. Okay, next one. Pause the video, have a go. Okay, it wants us to sketch this graph here. It tells us that a is bigger than 0. So, in order to do that, what I'm going to start doing now is I'm going to just consider the graph first of all. Y is equal to 2x plus a. Remember, a is a positive number. If x is equal to 0 here, then y is equal to a. If y is equal to 0, then x would equal negative a over 2. Just solving in there. Okay, so that gives us 2 points to draw the graph from. We know that the graph here goes through 0 and a. When x is 0, y is equal to a, so it'd be somewhere like here. And we also know when y is 0, x is negative a over 2. So it would go through somewhere like here. This would be negative a over 2 and 0. Okay, and the graph looks something like this. Now, making that graph a modulus graph, that was step 1, considering that. Step 2 is to actually say what the modulus means. Well, y would therefore be two things. It would be the positive 2x plus a for these points for x bigger than or equal to negative a over 2, and it would be the negative of 2x plus a for x less than negative a over 2. So really what we need to do is we need to reflect this point in this axis as such. Maybe I've made that slightly too big there, be like that, and really you don't want to include this, that was just for working. And we have included all the points that are important for us on the graph. On the same axis, draw the graph of y is 1 over x. So the graph y is 1 over x, I'll draw that in green pen. The graph of y is 1 over x looks something like that. Does it tell us anything? It's not saying anything about the domain of x, so we assume that x can be positive or negative. So the graph of y is 1 over x looks something like that. And obviously the black line was the line y is equal to mod 2x plus a. Okay, so we've done that. Explain how your graphs show there is only one solution to this. Well, let's just rearrange this first. We've got x mod 2x plus a, subtract 1 is 0. If I add 1 to both sides, x mod 2x plus a is 1. If I divide both sides by x, 2x plus a mod 2x plus a is 1 over x. This equation, equation 1 and equation 2 are equivalent. 1 and 2 are equivalent. And our drawings show, our graphs show, one intersection. So looking back at our graphs, the graph of 2x plus a crosses the graph of y equals 1 over x at one place. Therefore, equation 1 has one solution. Simple as that. And D, find using algebra the solution of this equation. So we end up solving 2x plus 1 is equal to 1 over x. Now, looking at our graph helps us here. We know that it's the positive point. We know that at this point x is bigger than negative a over 2. We're this side of the line. So we're looking at this branch, i.e. this branch of the modulus. So we're solving where this equals 1 over x. So all we've got to do is pick out the right side there, and what we're solving is the positive of that is 1 over x. Multiply both sides by x, I get 2x squared plus x is 1. Subtract 1 off both sides, 2x squared plus x, subtract 1 is 0. Can I factorise 2x, x, plus 1 and negative 1 is 0, and therefore x is equal to a half, or x is negative a half. Now, you have to ignore the x is negative 1 even. Now, x is negative 1, we're going to ignore that. There is no solution there, so we're definitely ignoring that. But we're going to use the solution x is a half. Okay, we're going to use the solution x is a half. And when x is a half, you can substitute back into either this or this to get what y is. Y must be equal to 2. And actually it didn't ask for y. So actually the answer is simply x is equal to a half. Okay, next question. Pause the video, have a go. Okay, we are going to try and draw these graphs here. I've already said f of x. I've just written it in f of x equals notation and g of x equals notation. Now, what I might do is do the easy part first. Okay, do the easy part first. Deal with g first. Now, all we need to do to plot this is have two coordinates. So we could say when x is equal to 0, what would y be? Y would be equal to a. And if we let y be equal to 0, i.e. y is 4x plus a, then x would be negative a over 4. Okay, and I'm just going to start drawing that over here. Okay, so when x is 0, y is a, a is a positive number, so 0a is something like this. And when y is 0, x is negative a over 4. So here we've got another point here, negative a over 4, 0. We've at least drawn in the easy part to this question. It looks something like that. And we would label that as maybe g of x. Okay, now, potentially the harder part here. Let me just actually make this a bit smaller. So we've got a bit more space. So there we go. Now the harder, more difficult part. Make that a bit smaller as well. That's the working for G. Now let's deal with F. F. Now F is, f of x is the modulus of x subtract a plus a. Okay, so if I was thinking to draw this, what I might do to draw it is I might substitute some values in, for example. I might substitute some values in. So what I might do is I might work out f of a. I might put a in there and I would get a back. So I know it goes through the point a. So a across, let's say, and a up. It goes through the point AA. I know that for a fact. What I might then do is also substitute something like 2a in there. So f of 2a, if I put 2a in there, 2a subtract a is a, mod a is a, and I get 2a back. So I know it goes through the point 2a, like that. Now what about something like, what if I put something like, let's say, 0 in there? What if I worked at f of 0? Well, f of 0, if I put 0 in there, I would get the modulus of negative a, which is a, and a plus another a is 2a. So I know if I put 0 in, I get 2a back as well. So it looks to me quite clear that having got those points, it looks like the graph ends up looking something as follows. It has its minimum value at a, because anything bigger than or less than a will make this a bigger number than 0. So it's got its minimum value at x is a, and its minimum value would be a. And therefore we've got the graph. And it crosses here at 0 and 2a. Use algebra to find in terms of a the coordinates at which the graph f and g intersect. Now look, we are dealing with this branch. This is the branch that will intersect with this line here. And it won't intersect later on because the gradient of this line is 1 and the gradient of this line is 4, so this is steeper, so they will never intersect again. So they only intersect at that point. So what we're trying to solve is this line equal to the red line, i.e. we are trying to solve the green line, which is 4x plus a, equal to the red line, and the red line is the negative of this plus a. So the red line, that would be f of x, would be the negative of x subtract a plus a. The negative part of this, which would simply be a subtract a plus a, which would simply be 2a subtract x. That's what we would be solving. So we're solving that equal 2a subtract x. What I can do, I can add x to both sides and subtract away a. So I would get 5x is equal to a. And therefore I would get x is equal to a over 5. It wants the coordinates. I found the x one. What is the y one? Well, the y coordinate I could get by substituting in x into one of these two here. So I could say the y one must be 4a over 5 plus a, which is 4/5 a plus 5/5 a, which is 9 over 5a. So x is 1/5 a and y is 9/5 a. That's supposed to be an a. Part 3, find an expression for f of g of x. Well, g of x, we know we were told previously was 4x plus a. F of g of x must be what I get when I work at f of 4x plus a. So I'm going to put in 4x plus a into this equation here. So f of x, we know that f of x is equal to mod x minus a plus a. So mod x minus a plus a. So f of 4x plus a must be when I put 4x minus a in there. So it's going to be mod 4x plus a subtract a plus a, which would be the modulus of 4x plus a. And that would be f of g of x. And for part D, solve for x in terms of a, this equation here. So what we're solving is mod 4x plus a. So we're going to solve mod 4x plus a is equal to 3a. So I'm going to solve two things, two strands. I might put that in the middle. On the one hand, I'm going to solve where 4x, the positive of this modulus, plus a equals 3a. And on the other hand, I'm going to solve where the negative of the expression inside the modulus plus a equals a. Subtracting a off both sides, 4x would be 2a, and dividing by 4x would be a over 2. And what could I do to both sides? I could subtract a off both sides. I get negative 4x is equal to 0. And then what I could do, sorry, that was 3a there. I've made a mistake. Sorry, that was supposed to be negative 4x plus a equals 3a. So I can't do that. But I can subtract an a off both sides and get negative 4x is equal to positive 2a. Divided by negative 4, x would therefore be negative a over 2. Our x is a over 2 and negative a over 2. There's our 13 marks. Next question, pause, have a go. Okay, our f of x is ln 2x subtract 1. X must be bigger than a half. And our g of x is 2 over x subtract 3. And x can't be equal to 3. Find the exact value of f of g of 4. Firstly, make your life easier by working out g of 4. G of 4 is 2 over 4 subtract 3, which is 2 over 1, which is 2. So therefore f of g of 4 is the same as working out f of 2. And if we put 2 into this function, that would be ln of 3. Nice and simple. Part B. Find the inverse f to the minus 1 of x and state its domain. F of x is ln of 2x subtract 1. So you always let y be ln 2x subtract 1. Just remember the domain here, it was x bigger than a half. Now, you rearrange this to make x the subject of the formula. Take exponentials of both sides, so e to the y must be therefore 2x minus 1. Add 1 to both sides and divide by 2. So firstly add 1 to both sides is 2x, then divide by 2, x would be e to the y plus 1 all over 2. Therefore f to the minus 1 of x, f to the minus 1 of x would therefore be equal to e to the x plus 1 divided by 2, which is a half e to the x plus a half. Now what's the domain here? What is the domain of this function here? Well, any x value can go in here. E to the x works for any x value, so x is simply a member of the reals. Okay, next. C, sketch the graph y is g of x, indicate clearly the equation of the vertical asymptote and the coordinates of the point at which the graph crosses the y-axis. So g of x, let's write g of x again down. G of x is 2 over x subtract 3, 2 over x subtract 3. And I'm asked to draw the graph, the modulus of this. Well, the first thing I do is, before I worry about the modulus, step 1, draw the graph y is 2 over x subtract 3. Okay, when x is equal to 0, then we get ourselves y is equal to negative 2/3. Actually, this one's not going to be easy to draw like that. It's easier to just think of this as a transformation. This is like the graph 1 over x. This will be very much like the graph 1 over x. I'm going to draw this in and rub it out in a second. It'll be like the graph 1 over x, apart from it's been shifted 3 units this way, and then it's been stretched in the y direction like so. Now, that would mean that this point here, this asymptote here, instead of being at x is equal to 0, it would now be x equals 3. So this line here, this asymptote, would be x is equal to 3. That is that graph. But step 2, the modulus of this, the modulus of g of x, well, that's like reflecting the negative part, making the negative part positive. So it would be like reflecting this up like so. And then we need to state, obviously, what that point is there. It asks us to indicate the coordinates where it crosses the y-axis. Well, where this crosses the y-axis is where the negative section of this graph, i.e. negative 2 over x subtract 3, you want to work out where x is equal to 0 here. You let x be 0, and therefore this gives you that y would be negative 2 over negative 3, which is 2/3. So this point here would be 0, 2/3. Part D, find the exact values for which the modulus of this graph is equal to 3. Where does this graph have the value 3? Well, let's draw the line y equals 3 in. There will be 2 points. One will be there and one will be there. So we are solving the modulus of this is equal to 3. So on the one hand, we are solving the positive of the expression in the brackets is equal to 3. And on the other hand, we are solving the negative of the thing in the brackets is equal to 3. So multiplying both sides by x minus 3 there, 2 would be 3x, subtract 9, add 9 to both sides, 11 would be 3x, divide both sides by 3, x would be 11 over 3. Or x would be equal to 3 and 2/3. Doing the same thing over here, I would get negative 2 is 3x subtract 9. Then I would add 9 to both sides, I would get 7 is equal to 3x. Divide both sides by 3, I would get x is 7 over 3, or x is equal to 2 and 1/3. Does that make sense on the graph? Well, this does look like the point, this does here look like the point 2 and 1/3, 3. And this here, sorry, that looks like the point 2 and 1/3, 3. And this one over here looks like the point 3 and 2/3, 3. So this one over here looks like the point 3 and 2/3, 3. And I've done. Okay, next question. Pause the video, have a go. Okay, k is a constant bigger than 1, and we've got our following functions. So I'm going to state that f of x is ln of x plus k. X must be bigger than negative k. And then g of x is the modulus of 2x subtract k. On separate axes, draw the graphs of f and the graph of g. On each, state in terms of k the coordinates where the graph meets the axis. Let's first of all do the easy one. Let's do f of x. Now, normally, a normal Lund graph looks something like this, and it crosses here at point 1, 0. So that's a normal y is equal to ln x graph. However, this graph is ln x plus k, so we are actually shifted over by k units in this direction. So we're going to be shifted over k units in this direction. Let's call ourselves there. So this would be equal to y equals x plus k, and this point here would no longer be 1, 0, it would actually be 1 subtract k 0. Draw that over there. 1 subtract k 0. Now, how do I draw this graph here? That's f done, so I might even write f of x there, f of x. I might actually just on a separate page draw this one. So I'm going to rub this one out here and draw this one on a separate piece of working. The first thing with g of x, I would draw the graph y is equal to 2x subtract k. Okay, when x is 0 here, y is negative k, and when y is equal to 0, x would be equal to k over 2. So x0 negative k, this would be the graph here. This point here would be 0 negative k, and this point here would be 0 k over 2. 0 k over 2. Now that is just the positive of that graph there. However, because it's modulus, the negative part of it is reflected up in this axis here, and instead of that being 0 negative k, it's actually going to be equal to 0 k up here, because it's just a reflection. And I'd actually rub out that point there, and I'd delete those there. And that is the graph of g of x is mod 2x minus k. Write down the range of f. Going back to f, looking at f actually takes all real values here. It's going down to negative infinity and going up to positive infinity. So simply stating the range would be as easy as writing f of x is a member of the reals. Find f of g of k over 4 in terms of k, given your answer in simplest form. Probably the easiest thing to do is to work out g of k over 4 first. Remind ourselves what g is. G is mod 2x minus k. So g of x is the modulus of 2x subtract k. Therefore, g of k over 4 would be the modulus of 2k over 4 subtract k, which is the modulus of 2k over 4 subtract k, which is the modulus of k over 2 subtract k, and this is the modulus of negative k over 2, but the modulus makes something positive, and we know k is already a positive number. It tells us that k here is bigger than 1, so we know the modulus of this just makes it positive. So g of k over 4 is simply k over 2. Now you should go down the page. I'm just going to go across for this particular example here. Therefore, f of g of k over 4 is the same thing as f of k over 2, because g of k over 4 is k over 2. So we know that f is ln x plus k. So this is equal to ln of k over 2 plus k, which is simply ln of 3k over 2. And you're done. Last part, the curve with equation y equals f of x. The curve C has equation y is f of x. The tangent to C at the point x equals 3 is parallel to this line. Find the value of k. Well, firstly, if we want to, we're using the fact that it's parallel to this line, the tangent to the curve. So what's the gradient of this line? Well, dividing by 9, it would be 2/9 x plus 1/9. So therefore our m here is 2/9, using y equals mx plus c. If an equation's in that form, the m automatically tells us the gradient. So I know the gradient of the tangent is 2/9. Okay, well I also know that the graph is y is f of x. Well, that's equal to ln of x plus k. So that's ln of x plus k. That's the graph. So what's dy by dx? dy by dx is the differential of the brackets, which is 1, over the original bracket, x plus k. Now I know that is also the gradient of the tangent at any point. So in particular, dy by dx at the point x is 3 is therefore 1 over 3 plus k, subbing in x is 3 here. So all I've done is substitute x is 3 in here. Okay, now again you should work down the page, not across, so I'm moving over here. But you know this is the gradient of the tangent at 3, but you also know it has numerical value 2/9. So you know 1 over 3 plus k must be 2/9. So multiply both sides by 9, multiply both sides by 3 plus k, you get 9 is equal to 2, 3 plus k. Expanding the brackets, 9 is equal to 6 plus 2k. Subtracting 6 from both sides, 3 would be 2k. And then dividing by 2, k would therefore be 3 over 2, or k would be 1.5. And you're done for 4 marks. Okay, next question. Pause the video, have a go. Okay, first part. We're told a lot about the graph, but effectively all this stuff says here is labelled on the graph. It says, draw on a separate diagram the curve with equation y is equal to 5 of x plus 1. Now that type of transformation, I'm just going to draw in over it here. Make those red, and I'm also going to group it. Now, that transformation there is a shift by 1 unit to the left. So it'd be a shift by 1 unit to the left, as so. And so we could then write our various coordinates in there. Our coordinates would therefore be, this here would be the point 0a, this here would be the point 2, and this here would be the point -2. It's as simple as that. Okay, next one, f of modulus of x. Now, this transformation, what this transformation does is it copies everything it sees on the normal f of x graph. And then what it does is for x positive, and then what it does is it copies, it reflects everything, all the values of y for x positive when x is negative. So it actually does something like that, and it makes us have a w. Now that point there, by symmetry, would be -1a or -1a, and by symmetry, that point there would be -3 and 0. And you're done. That actually should be, just, you know, to make it absolutely clear, that should be parallel to that line as such. Okay, then given that f of x is actually equal to this, find the values of a and b. So we are told that f of x is actually the modulus of x minus 1, x subtract 1, subtract 2. Now, what were a and b all about? Go back to our original. When you put 1 into the function, you get a back. When you put 0 into the function, you get b back. So we can solve when x is 1, f of 1 is equal to a, and when x is equal to 0, f of 0 is equal to b. So therefore, substituting in, f of 1 is therefore the modulus of 1 subtract 1, subtract 2, this is 0, so f of 1 is -2, and that is equal to a, so a is equal to -2, and f of 0 is the modulus of -1 subtract 2, the modulus of -1 is 1, 1 subtract 2 is -1, and this therefore is equal to b, so b is -1. D, find the value of x for which f of x is equal to 5x. Before we launch in and try and solve it, let's go back to the original f of x graph. Here it is. And if we drew remember this here and this here, this has steepness of 1, because it's got one x in it, is y is some lots of x. Okay, now if we drew the graph y is equal to 5x, the graph y is 5x is a steeper graph than these, and we can clearly see that these two lines will never meet, but this line here and this line here meet, so the solution would be some negative number, some negative value of x. So what we're doing is we want to solve where that branch is equal to y is equal to 5x, and that branch from the previous part, this would be y is the negative of this, y is negative x plus 1 subtract 2, or y is negative x subtract 1. We want to work out where y is negative x subtract 1 is equal to y is 5x. So they're the simultaneous equations we're going to try and solve. We are solving y is negative x subtract 1 and y is 5x. We make them equal each other. Negative x subtract 1 is 5x. Add x to both sides, negative 1 is 6x. Divide both sides by 6 and you get x is negative a sixth, and you're done. Next question, pause the video, have a go. Okay, for part A, we're simply asked to sketch this graph and show the points where it meets the axes. Easy as always, these ones. So all you do, first of all, you forget that there's a modulus, and step 1, you draw the graph y is 2x subtract 5. When x is 0, y is negative 5, and when y is 0, x would be 2.5. We've actually drawn this one before. So actually this, why don't I draw it like that? This point here would be 0, negative 5, and this point here would be 2.5 and 0, and we would draw ourselves a line between the two as such. So that's that graph, but we're drawing the graph of f of x is the modulus of 2x subtract 5. So this, what this does is it actually makes anything that's negative, any y value that's negative, actually positive. So it actually reflects it up as such. So this point there, instead of now by symmetry, this would be the point 0, 5. And actually what we should do is really rub this bit out here because it's confusing the examiner. And there we go, that is our graph there. Part B, find the values of x for which f of x is equal to x. Now, if I drew the graph y is equal to x here, y as x looks something like that. There will be two solutions, one here and one here. When this branch of the line equals y equals x, and when this branch of the line is y is x. So there are two things to solve here. If I'm solving f of x is equal to x, on the one hand, I solve the positive of this is equal to x, so 2x subtract 5 is equal to x, and on the other hand, I would solve the negative of the expression inside the modulus is equal to x. So I can subtract x off both sides and add 5, and I would simply get for this that x is equal to 5. And for this one, multiplying out, negative 2x plus 5 is equal to x. Add 2x to both sides, 5 is equal to 3x, and divide both sides by 3, I would get x is 5 over 3. So one of my values is x is equal to 5, the other is 5 over 3. Looking at our graph, that looks about right. And then it says a function g of x is defined as follows. G of x is equal to x subtract 6, and it says find the range of g of x. Well, all we have to do for that is draw the thing. Well, it's obviously a quadratic if you expand it out. It has roots at 0 and 6, and it's a positive quadratic, so it looks something like this here. The range of it, well, it's all values bigger than this point, bigger than that point there. Now, where is that point? Well, it's halfway between 0 and 6, so it's going to be 3. It's going to have an x value of 3, and the y value associated with that would be 3 if you subbed in 3 into the function. 3 multiplied by 3 subtract 6, which is 3 multiplied by negative 3, which is negative 9. So therefore g of x must be bigger than or equal to negative 9. And the last part, find f of g of 1. G of 1 would be, substituting 1 in here, would be equal to 1, 1 subtract 6, which is equal to negative 5. F of g of 1 would be f of negative 5. Looking back at our definition of f, if x was negative 5, it would be this branch here, where it would have a value. So let's stick in negative 5 into this. This would be the modulus. It's of 2x minus 5. Yeah, it's the modulus of 2 times minus 5 subtract 5, which is the modulus of negative 15, which is simply 15. And f of g of 1 is 15. And we're done. And now we've done all the questions that come up on solving modulus equations for the Edexcel Core 3 syllabus. I hope you found that useful. Thank you very much for watching.